Hi. Start over.
No, we're not starting over.
Start over. Seriously, start over.
Just keep playing.
No, seriously. This time it's for Rizzo. Alright? Just tell me when you start.
Go.
Go.
Start over and say 3, 2, 1.
3, 2, 1, go.
Hello. Group 3, me, Calvin, Nick, and Matthew are here to talk to you about Lesson 2.1. Now there are 6 main parts in Lesson 2.1. Centroids, beam deflections, free body diagrams, force vectors, moments, calculating thrust forces. Now that's a lot of math, but we're going to walk through everything slowly and hopefully in a very clear and concise manner. So we're going to start with centroids. And centroids are defined as an object's center of gravity or center of mass, and is usually graphically labeled as something kind of like this. And this is usually placed at the centroid in an object. Now, the centroid principles are points of applied force caused by acceleration due to gravity. In kind of layman's terms, that really just means where it balances out. An object is in a state of equilibrium if balanced along its centroid. That's like when you take a ruler and you put it on your finger and you get it just in the middle so that it balances without falling either way. So, the question that we're going to be asking is, how do you find an object centroid? And you find an object centroid location it's actually quite easy, by utilizing the cross-section view of a three-dimensional object. So, first what we're going to have to find is the cross-sectional view. So, centroid location is symmetrical objects, for symmetrical objects. And it's determined by an object's line of symmetry. So, there's three, for example, we're going to use 3 objects. Alright, a triangle, a square, and a circle. So, a centroid is found at the line of symmetry in a shape. Alright? So for a triangle, since it only has one line of symmetry, we found in the middle of that said line, right there. A square, a square, since it has 2 lines of symmetry, well, multiple lines of symmetry, we're just going to use the diagonals. So we find in the middle where they intersect, as my friend Nick said. And then a circle finally has an infinite number of symmetrical points, but we are able to find the center. And can therefore find a centroid. Now, for shapes that are semi-irregular, there is a formula to how to find a shape. The formula for a square or rectangular shape is quite simple. X equals base divided by 2, and y equals height divided by 2. Now, you might be wondering, what's this funky little thing right there? Well, that's the actual distance for the centroid. It's just a way of marking it so that it's different distance from x. It marks the origin. Now, for a triangle, the formula is 1/3 its base and 1/3 its height. So it's the same exact thing, except divided by 3. Oh, whoops. Height. And then a centroid of a circle does not follow the same It's 4r over 3 pi. So an example of this would be if there was a semicircle, and this is 2 2 inches, right? So it would be 4, 2 over 3 pi. Multiply a divided by 3 pi. When you divide, you end up with 0.8 inches. And that is where the centroid is. Well, you really end up with 0.849 inches. And that's where the centroid is located away from the axis. Pause the video. Pause it. Unfortunately, what I just told you guys only works for non-complex shapes. For complex shapes, you're going to have to use this formula right here. For x and then vice versa for y. It's the same exact formula, except this is a y and that's a y. And then, alright. So, for a complex shape, let's just say the complex shape looks like this. Right? You first have to divide it into sections. So we're going to say this into non-complex shape. So a triangle, rectangle, and a rectangle. So the next is calculate.
Go.
The next is